instruction I'll use, that also I'll discuss, so that entire is all instruction sets will be covered. So as we discussed in last class, right, the timing diagram, right, by seeing the timing diagram, you can see, you can understand how many T states an instruction takes, right, or 8085 takes to execute an instruction. How many T state the processor requires in order to execute any instruction. Like in this case, it is LHLD and SHLD instruction, right? 4 and this 1, 2, 3, 4, 12 plus 4, total 16 T states are needed in order to execute these LHLD and SHLD 3-byte instruction. Similarly, for LDA, STA, right, call instruction is also there, which takes maximum T state, around 18 T states. That is very, very important, right? Call instruction takes 18 T states. So lengthy instruction. This one is this maximum T states. It takes max T states taken by 8085, right? So anyway, so in last class, right, we were discussing timing diagram, and today we will start with the delay program, right? Delay program. So in order to discuss the delay program and use of understand the use of delay program, right, I'm giving you an example. Suppose here in memory location 2400 onwards, right, we have 8 bytes stored. 8 bytes are there. 2407, right? Here we have 1 byte, say x1 x1, next byte x2 x2, x3 x3. Similarly, x8 x8, 8 bytes are there. Now we have to, these bytes are inside memory, right? We have to print them, right? We have to print x1 x1, x2 x2, x3 x3, right, byte by byte, right, using a printer. And for that, of course, we need IO ports, right? On that port, printer will be connected, and you have to read these bytes from memory, and you have to out them in that port, so that printer will print. Now suppose that port address, right now, in fact, IO port we haven't discussed, right? In 8255 peripheral, right, chip is also there in syllabus. That time it will be discussed. So let us say, let us assume that if we store this byte at, say, these bytes at, say, 2800, right? If you read this x1 x1, and if you put over here, then it will be printed by printer, right? Then if you read x2 x2, if you put over here, then x2 x, this byte will be printed by the printer, right? So let us write the program for this first, right? Our program is starting from, say, 2000H. Very, very simple. First program will be what? First instruction will be LXI H. Okay, let us go with this B. LXI B 2400H. Next instruction will be MVI E 08H. Now, if you do LDAXB, Ankita Kumari,
Yes, sir.
what will be the content of A if this instruction is executed? Quickly. It means you are not following all these things, no? Why I am doing LXI B 2400H? Hello? Anyone can respond quickly. What will the content of A after LDX be?
08.
So that I can proceed.
Sir, A will be 2400. Sir, A will be 24, sir.
A will be
2400.
A will be 2400. A is 8-bit register, right? And 2400 is 16-bit. So how 2400 will be A?
Sir, because we are using the X command, no sir. X command generally we use for 16-bit register, 16-bit, no sir. So I don't know that, sir, but maybe it might be possible we are storing it in temporary register.
Sir, the contents of B will be stored
Loads
in
the
A.
content from B and C registers.
Yes, sir.
Achha. Okay. Very good. Right. This LDXB, see, if you go through, I discussed these instructions, LDXB, stacks B, all these things. LDXB stands for LDA, stands for load accumulator. X stands for extended BC pair, extended BC register pair, right? And in BC register pair, we have 16-bit data. So accumulator cannot be loaded with 16-bit data, right? So this actually means, right, whatever data we have inside the BC register pair has to be treated as address of the data. So in BC register pair, what we have moved? We have moved B equal to 24, C equal to 00. Now this BC register pair will be used as memory pointer in this instruction. Right? I'm writing this LXID. LXID, if I write comma 0008. So D will be 00, E will be 08. Now LDXB, this instruction will copy the content of memory location pointed by BC pair. So BC is having 2400 and content of memory location pointed by BC pair is X1X1. So this will have A equal to X1X1. Now if I do STA 2800H, what exactly this instruction is going to do? Anyone? Quickly.
Sir,
Loads the content of
Sir,
A to
store the
2800.
contents of A in 2800.
So content of A
Address
is
location.
what? X1X1.
Yes, sir.
So it will be, suppose here we have some data YY earlier. Now, when this instruction is executed, accumulator content will be stored here. So here it will be now
X1X1.
X1. So printer will print. this x1. Next, I am doing this INX B. What exactly this instruction is going to do? It is going to increment the BC register pair we discussed earlier. Right? ऐसा नहीं कि हमने वो डिस्कस नहीं किया होगा. Right now BC is how much? 2400. So when INX B is executed, INX B is executed by the processor. BC pair will be incremented by coming over here. 2400 will become 2401 in this incremental decremental latch, and it will go back to this. In this process, arithmetic logic is not being used, so flags are not affected. ये बात हमने बोला है पहले भाई. Okay, so now BC will point to 2401. Okay, next instruction will be DCR E. E is how much? E is 08. D is 00. So if DCR E is executed, how it will be done? This E will move to temporary register, right? And from here, it will be decremented. 8 minus 1 will be done, and it will be 7. Then this 7 will go back over here, and from here it will go back to E register. And in this process, arithmetic logic is involved. Arithmetic logic circuitry is involved. So in this decrement process, final result is 07. And based on this result, flags are going to be affected. Right? So now result is not 0. So this 0 flag will be 0 in the flag register. 0 flag will be 0 in the flag register. So now I am writing a conditional jump instruction, J and Z. Jump if not 0. Jump if 0 flag is not 0. Repeat. So we have to repeat this instruction for printing this x2 now. So where it should go back? कहाँ पे जाएगा जी? Where should I level repeat? Here. Hello? Where I should put this repeat level so that this printing of x2 will be done. Anyone quickly? Hello?
Sir, near LDAX.
Near not. Oh, okay. So repeat has to be over here. So imagine right now, next LDX B will be executed. After here, it will repeat this. So LDX B, what is BC now? BC is 2401. So what will be A after this? Quickly. BC is 2401. So
Content of
2401 will be A now. So it will be x2. Okay. Now STA 2800. So A, which is x2 will be stored over here. Now printer will print this byte. INX B. So it will be BC will be incremented by 1. So it will be 2402. DCR E. So E will be 7 minus 1. So it will be 6. Again, result is not 0. So it will jump back over here. Now it will load. Then it will be stored at 2800. printer will print. Hello? Is this sequence is clear to you how it is going to print the data? X1, X1, X2, X2, X3, X3. Hello? क्या हुआ भाई? BC is over here. So A will be how much? When LDXB is executed, A will be X8, X8. Right? Then STA 2800, X8, X8 will be kept over here and it will print. INXB, BC will be how much? BC will be 2408. Right? And what will be E after that? E will be that time it will be 1 only. E will be equal to 1 minus 1. So it will be 0. So when E content is 0, when it is say E is 0, 1, it is decremented over here. Result will be 0, 0. So again it will go back to E. So that time when it is E was decremented by 1, results become 0, 0. So this 0 flag will be set to 1. Right? So this condition, jump if not 0, is going to be false. So it will come out of loop and halt will be over here. So I am rewriting this instruction over here, new slide. These instruction over here. LXI B 2400H. So suppose our program is starting from 2000H. Here it is going to be LXI B of code. Right, next 2001, what we will have? We will have 00. At 2002, it will be 24. Hello? 2403. We have what? LXI D 0008H. So here opcode of LXI D will be stored. Then at 2404 it will be 00. At 2405 it will be 08. Next instruction is what? LDAX.
Sir, first 08 will get stored, no?
Oh, sorry, 08 will be first, then 00 will be over here, right? Okay, 08 will be over here. Okay, thank you. LDAXB. So at 2406, this will be what? LDAXB opcode will be over here. Then STA 2800H. So STA opcode is 32, right? So at 2000, no? 2000, sorry. All are 2000 only. 2007, 32. This is opcode for STA, right? Similarly, LDXB opcode, LXIB opcode will be in these locations. At 2008, it will be this lower order address byte. Then 28 will be over here at 2009. Next location will be 200A. At 200A, which instruction we have to write after STA? It is INXB. So INXB opcode will be over here. Then 200D. DCR E instruction has to be over here. And next instruction is JNZ loop or repeat. Loop is over here. So here you will have opcode of JNZ 200C, this location. In next location you will have loop address. So 0P LO has to be over here. 200B 200E. So what is this? LOOP. LOOP is nothing but this 2006, right? So 06 will be over here, and this will be 20. So our coding has to be like this. This will read data from 2800 onwards. Now 2400 onwards, and all those bytes will be stored at 2800, which is connected to printer. Right, which is connected to printer. After this 200F, here you will put halt 76 of your instruction. This is end of your program. Now, in order to read these bytes x1, x1, x2, x2, x3, x3, and print them, right? You have to read these bytes and you have to store them in 2800. So how you will do? You will execute your program. You will execute your program, which is starting from 2000H. So you will set program counter equal to 2000H first. So when you start executing your program, you have to give the starting address of your program, which is 2000H. So first of all, program counter will be outed 2000H. LXI B opcode will be fetched. Then corresponding machine cycles will be generated after decoding. Right. This LXI B opcode will be fetched to instruction register over here. Opcode will be fetched to instruction register. Right now, program counter is 200H. So during T1, program counter will be outed. During T2, program counter will be incremented by 1. During T3, LXI B opcode will be fetched to instruction register. Then corresponding machine cycles will be generated. Right. Then what will happen? Machine cycle will be generated. Right. 2001 will be outed. 2001 will be outed. This 00 will be fetched. It will be stored in B register, then C register, then program counter will be incremented, right? C will be equal to 00, B will be equal to 24, then 2003 will be outed, LXI D opcode will be fetched, 08 will go to E register, 00 will go to what? D register. Then LDX B opcode will be fetched. Accordingly, content of memory location pointed by BC pair x1 will come to accumulator. Then STA 2800 will be executed, right? And x1 will be stored at 2800. Similarly, INX B, DCRE, JNZ. Finally, it will keep on looping this. When condition is not true, then it is going to come out of the loop. If condition is true, then program counter will be loaded with 2006. So again, it will start executing one by one instruction from here. right? Again, program counter will be loaded. So loading of this program counter will be done how many times? 8 times. No, 7 times. 7 times it will be loaded. LDXB, and then it will come out of the loop. Hello? Is this process is clear?
Yes,
How
sir.
program counter, see, program counter is going to execute your instruction one by one. So it keeps the track of your instructions, which has to be executed next. Right? Now here J and Z is a branch instruction. If zero flag is not zero, then program counter has to be loaded with 2006. Right? If zero flag is zero, then program counter will be loaded with 2006, and if zero flag equal to 1, then program counter will be as it is 200F. Okay. Now actually all these things we are discussing in order to discuss the delay program. Right? Now what will happen if this printer takes 5 seconds to print X1 and processor execute this loop within say 5 microseconds. Hello? If this printer is taking say 5 seconds to print a byte, while this processor is transferring bytes to these location, to this location 2800, it reads X1 very quickly, it puts over here, right, within 5 microseconds. Right? Then it reads X2, again it puts over here. So printer is still printing previous byte. If you put the new data, then printer will be confused, no, which data has to be printed. Right? So this data will be overwritten and printer will print you a garbage thing, right? Garbage type of print will come. Right? So suppose now if we introduce a delay over here, JNZ loop, right, and loop will be over here, and here we write a delay program of call delay of 5 seconds, 6 seconds. Either you call your delay of 6 seconds over here, or you call a delay of 6 seconds. Right? So what we are doing now, loop will be over here, loading the data from memory location, storing it at 2800. Printer starts printing this, right? INX B is executed, DCR E is executed very quickly. Printer is still printing. Now this delay program will be executed by the processor. So processor is going to execute this one for 6 seconds. So by this time, of course, printer will finish the printing of previous byte X1. Now it is jumping back to this. No. This DCRE has to be below this, because DCRE has to be below this, and then all delay. Now, then J and Z loop. Right. So 6 seconds is over here. Printing is over. Now count is decremented and it is going for next printing. Next byte is fetched. It is stored in the printer location. Right. Pointer is incremented. It is waiting for 6 seconds over here. Right. X2 is printed. Right. Then again count is decremented. It is going for printing the next byte. Okay. So here you can find the use of delay program. Now I am going to write a delay program, new slide over here. So delay program or delay subroutine. I am writing this delay subroutine. Delay subroutine. Right. First instruction is MEI C, 46H. What exactly this instruction is going to do? Move immediate, right, 46, move immediate data 46H to C registers. So C will be 46. Next is DCRC. Right, it will decrement C by 1. Then another instruction is J and Z again. Again will be over here. Right. So J and Z again means again C will be decremented. So it will be C will be 45 minus 1. C is 0? No. So it will again decrement. It will keep on looping over here. So how many times this DCRC will be executed? Then it becomes 0. Anyone? Abhishek Agrawal. How many times this DCRC will be executed? Then C register content will become 0. How many times? Abhishek Agrawal. How many times it will be executed? I am going for Ankit Kumar.
So 46.
46. 46 times. 46 is 4 into 16 plus 6 is how much?
64. Oh, okay. 70.
70. Right. So it will be decremented 70 times. Right. Processor CPU 8085. Right. Here, whatever arithmetic logic circuitry is there, it's a binary arithmetic and logical circuit, not decimal one. Right. So it will be decremented how many times? 70 times. Now I'm putting one instruction NOP. Then I'm writing one instruction RET. Now we have to find out how much time will be taken by the processor in order to execute this delay subroutine. So how much delay will be generated, how much time CPU will take in completing this delay subroutine. So now you can see how many times this instruction will be executed, MBIC 46H. How many times? Suppose program counter is here. It is executing MBIC 46H. Then program counter will be over here. It will execute DCRC. Then program counter will be over here. It will execute JNZ again. Then finally program counter will be over here. It will execute NOP. Then finally program counter will be over here, return. And from here it will return to main program. Main program is where? DCRE. Over here it will return. Hello? So how many times this MBIC 46 will be executed?
Sir, 46 times.
MBIC 46, how many times it will be executed? Program
Seven
counter is here.
times.
Huh?
7 times.
7 times. Why 7 times? How this program, this value, this address, suppose it is at say 2700H. So program counter will be at 2700H. Right, it will be incremented to 2701H. It will be incremented to 2702H. Then it will be incremented to 2003H, 2004H, 2005H, 2006H. This will take 2 bytes. This will take 1 byte. Right. This will take 3 bytes. NOP will take 1 byte, and this return will take 1 byte only. So MBIC 46H will be executed how many times? 2700, 2701, 2702. So again is 2702. So it is looping back over here. How many times? 70 minus 1 times. It will be 69 times. It will loop back. And then it will come over here. Then from here it will return to main program. So program counter will come to this whenever this delay subroutine is called 2700H. MBIC will be executed only once. DCRC, because here so looping is there, so it will be executed 69 times. Right, then it will come out of loop. It will execute NOP instruction for once, then it will execute return instruction for once. Now, if you go through the instruction set, then you can find out how many T states this MVI instruction takes. So it takes 7 T states. DCRC, how many T states? DCR, INR we discussed in last class, no? कितना T state लेता है जी?
4.
4 only. 4 T states. JNZ, JNZ takes how many T state? 10 T states if this condition is true. And if the J and Z condition is false, then it takes only 7 T states. 7 T states. Right? And NOP, NOP instruction takes only 4 T states. Return instruction takes 10 T states. Return instruction takes 10 T states. So now you can calculate total number of T states taken by these, right? Taken by the processor in order to execute this. So 7 into 1, those many T state it will take. Then 60 DCR-C will be executed 70 times. Sorry, earlier I said it will execute 69 times, but it will be executed 70 times, then it will become 0. How many times J and Z? Again, this condition will be true. It will be true for 69 times. And it will be false for 1. NOP state will be executed once, and this will be executed once. So total number of T states, 7 plus 270, 280. So 280 plus 690 plus 7 plus 4 plus 10. So total is 998 T states. 998 T states. Next. So if our processor is running at say 3.085 megahertz, 8085 runs at 3.085 megahertz. So how much is the duration this of one T state? ये कितना होगा जी? 1 by 3.085 microsecond will be this duration. So this multiplied by 1 by 3.085 microsecond it will take. Is it not? Hello?
Yes, sir.
Right. So now you have to put the count value over here, proper count value over here, so that this becomes 5 seconds. New slide. I'm writing this delay program now. Okay. LXI B 2400H, right? LXI what? B 0008H. LDAX B STA 2800 na? Right. INX B call delay 5 sec. Delay 5 seconds. Then DCR E JNZ loop will be over here. Loop will be over here, right? And here will be halt. Now our delay program, call delay high sec, is here. 5 seconds will be over here, and it will be final instruction is RET. So suppose our this delay program is starting from, say, first one is MVIC. This is our delay program, and this one is the level. This address is, say, 2700H, right? So here you will write what? Call delay. In fact, it will call 2700H. So how it will be done? First of all, LXI B will be executed, LXI D will be executed, right? LDX B will be executed, STA 2800, INX B, right? Then call delay 2700 will be executed. In this process, when this instruction is executed completely, then program counter will be over here. This is a 3-byte instruction, so program counter will be over here. So when this instruction is executed, next instruction address, which is at program counter, is actually pushed to the stack. So suppose DCR E was in which location? DCR E was in at 200B, right? Suppose DCR E at 20, of course, right? Suppose this location is, I am writing this is XX YY. This one is the location where DCR E is there. Means after this call instruction, processor has to execute this, decrement this count. So for decrementing the count, instruction is over here, XXYY. So after executing INX B, it will execute delay program, so that 5-second time is given to printer, right? But after that, right, count has to be decremented, DCRE has to be executed. So address of the next instruction is actually pushed to the stack. So YY will be over here, XX will be over here, and this will be SP, the stack pointer. Great. So when call instruction is executed, right, this is 2700, which is the subroutine address, is fetched. Then next instruction address is pushed onto the stack. Then it branches to 2700H. So here it is executing. When return instruction is executed, program counter will be this over here. When return instruction is executed, then program counter will be somewhere here. Suppose it is ending at 2700. So suppose it is 200A. So program counter will be at 200B, right? So when this return instruction is executed, processor is going to understand now it has to branch to main program. So main program, which location? This loop, STA, INX, or LXID? No, that address is stored in this stack, right? So XXYY will be loaded to program counter whenever this return instruction is executed. So program counter will be over here and count will be decremented, JNZ loop. So it will go back over here, LDXB, STA 2800, INXB. Again, it will branch to this 2700, but before branching, XXYY will be pushed on to the stack. Hello? Is this process is clear? How a subroutine is executed by the processor? Right, and this instruction takes around 18 T states. 18 T states is taken by call instruction. Right. DCRE. Now I will write some delay programs over here. Now MVI C46H, DCRC JNZ again is here, right? Then RET. This is one. Next we can write this MVI B say 03H, MVI C 46H, DCR C JNZ again will be over here. Now next we can do DCR B. Again will be over here. Sorry. DCR B, JNZ again 1. So again 1 will be over here. Now how many times MVI C46 will be executed? This will be executed once. How many times MVI C46 will be executed? Quickly. Hello? Hello?
Yes, sir.
कितना बार MVI will be executed?
Sir, 1 second, sir.
Here MVI will be executed once. DCRC will be executed 70 times. JNZ will be looping back over here 69 times, and then for once it will be, then it will come over here, right? So 69 into 10 plus 7, then return will be executed once. In this program, in second one, how many times MVI B03 will be executed? Once. But MVI C46, how many times? Hello? अरे भाई कोई तो बोलिए. How many times it will jump back to again 1? Or if I'm writing
3 times.
हाँ कितनी बार जाएगा जी लूप 1 में? 3 times, right? So MVI will be executed 3 times. So how many times DCRC will be executed now? 3 into 70. Similarly, JNZ again 3 into 69 plus 3 into, right? These many times it will be executed. DCRB कितनी बार execute होगा जी? 3 times. This JNZ again 1, how many times? 2 times. Then it will come out of loop. So this is a delay program using two registers. New slide. Now I am writing another delay program having two register, but instruction I am changing. Now I am writing LXI B 0346H. Now we can write, say, instruction DCXB. So now BC pair will be decremented by 1. BC minus 1. Hello? Earlier we were using DCRC and DCRB separately. Now we can have an instruction DCXB also in order to decrement the register pair. So how many times we do this DCXB? DCXB, then it becomes, BC becomes, say, 0000. कितनी बार करना होगा? Hello?
838 times.
How many times? 838 times. Right. Now, can we write this instruction over here? JNZ loop RET. Can we write? Hello? Hello? Can we write this JNZ instruction like this so that this BC register pair is decremented, say, 838 times, and it will loop? Huh? Hello? आप लोग कुछ ध्यान नहीं दे रहे हैं भाई. How many times we discussed this? Right. Right now, how much is the BC? BC register we have put 0346. No. So for DCRC, C was taken over here, and here it is decremented. For DCRB also, it is taken to temporary, and here it is decremented. So flags are affected. But when this DCX instruction is executed, DCX B, right, DCX H or DCX D, if these instructions are executed, how this register pair are decremented? These register pairs are decremented over here in the incrementer decrementer latch. So flags are not affected. So we cannot write. I'm not sure how 8085 is doing this register pair decrementing, but I'm just giving you the hint. It is not being done inside ALU, or otherwise flags are going to be affected. So I'm seeing incremented decrementer latch, program counter, stack pointer are incremented decremented over here. So same way BC, DE, HL register pair also can be incremented decremented whenever INX DCX instructions are executed over here. Right. So what should be the instruction then? We can do like this: move A, comma B. So content of B will be copied to accumulator. Now the B equal to 03, C equal to 46. Now if you do DCXB, what will happen? B will be equal to 03, C will be equal to 45. Now if you move B content to A, So A will be equal to 0, 3. Now if you do this, ORA C. So 0, 3 will be odd with 45H. Now result is going to be what? 0, 3 is 4 zeros. 1, 1 is 3. This is 4. And this is 0, 1, 0, 1. So bit by bit ORing will be done. ORAC. If ORAC is over here, what will happen? C content will be copied to temporary, which is 45. B is 0, 3. A is 0, 3. So bit by bit ORing will be done over here. And based on the result, flags are going to be affected. And result will be stored back in the accumulator. So what will the result of bit by bit ORing? 1, 1 OR is 1. 1, 0, 1 is, if you OR, then it will be 1. This will be 1. 0, 0 ORing 0. 0, 0, 1, 0. So it will be 4, 7. So result will be 4, 7. So in this OR operation, does this result become 0? No. So J and Z loop now you can write. Now, suppose this is now C equal to 0, 0. Right. Now, suppose this BC is decremented so many times, and finally we are having this content. BC is 0, 3, 0, 0. Right. Now, if it is further decremented, what will happen? C will be equal to FF, and this will be 0, 2. Finally, it will become 0, 2. C will be 0, 0. Further, it is decremented. B will be 0, 1. C will be equal to FF. Right. Then again, it will be decremented how many times? 0, 1. C will be 0, 0. Next time it is decremented, it will become 0, 0, and C will be equal to FF. Further, it is decremented how many times? 255 times. Then C will be equal to 0, 0, and B will be equal to 0, 0. So this way, kitna bar hoga? 836 times it will be decremented. And finally, both register content B and C will be 0, 0. And if you go by these two instructions, then this loop is not going to be true. Finally, after 830, right? Hello? How many times this BCPR will be decremented? Someone said no, 830.
838.
838 times, right? So after 838 times, BCPR is decremented, both will become 0. Then these two instructions will find out both register contents are 0. So then this loop is this J and Z condition is not going to be true, and it will come out of the loop. I hope difference between DCX and DCR instruction is clear. Of course, this delay programs will be very, very complicated if you go for, right, 5-second delay calculation is going to be very, very complicated one. and large delay you cannot generate by writing these programs, these subroutines. So in fact, we have separate circuit, separate IC is there, timer IC is there, 8253 in your syllabus, where exact amount of timing you can calculate and you can interrupt the processor. No need to write all these delay programs, right? Computing the how many t state it takes, multiply this one by 3.085 megahertz, right? So this much second, no need to do that, right? So 8253 timer we have in our syllabus, we will discuss, right? Probably it is in module 3 or 4. Okay, today datacom lecture is not going to be there. Fundamental of data communication, FDC, no? Fundamental of data communication lecture is not going to be there. So I will engage, right? It is at 3:30 p.m. no? Hello? Very, very important one, logical operation, right? Rotate, right? Rotate instructions are there. Then we will discuss BCD, arithmetic also, because in second program, both this rotate as well as BCD arithmetic is needed, right? In that second program. So, okay, so I am closing this meeting now, right? See, whatever study